Swayam Prabha. Digital India. Educated India.
Hello all, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. I am Rajaram Lakkaraju from Mechanical Engineering, IIT Kharagpur. From today onwards, we will cover module number 3 with lecture number 21, orthographic projections. In the last two classes, we have covered introduction, geometric constructions and conic sections. From now onwards, orthographic projections in two modules we will cover, that is for module number 3 and module number 4. Our textbook is Engineering Drawing by N.D. Bhatt and Panchal and others. Our sincere thanks to Professor Akhilesh Kumar Maurya for his excellent materials provided online on orthographic projections. So, most of the slides information is inspired by his works and taken with his permission. First question we will ask, what is an orthographic projection? An orthographic projection is a technical drawing in which different views of an object are projected on different reference planes, observing perpendicular to respective reference planes. So, it is a technique of showing different views. The different reference planes can be a horizontal plane, which we denoted by HP, a vertical plane we denote it by VP, and side or profile planes by PP. These are the standard conventions for engineering drawing to locate different reference planes as horizontal plane, vertical plane, side or profile planes. The different views of a drawing can be the front view, that means we are going to project it onto the vertical plane, a top view projected onto horizontal plane, a side view projected onto profile plane. For example, if we have a rectangular block, let us call letter A side, B and C. If this block we would like to project it, for example, let us take a light lamp which is shining light. So, this plane A, if we are going to project it on a sheet plane, this plane is a vertical plane. So, this is what we call vertical plane. If we project it, we can't see anything back side of that object, we can't even see the side things in most of the cases, we can't see anything like top view things. Only what we can see is A, we will be in a position to see. Only we will be in a position to see A if we are having a shining light onto that object. This kind of thing is called what? Projection of this surface onto that plane. Here the plane is a vertical plane, and what we are projecting is in this direction we are projecting. Similarly, for the same object, A, B, C. If you are going to view it from top or a shining light is coming from top, we can't see what is A, what is B for this parallelepiped rectangular thing. When we are projecting, what we can see is on this horizontal plane, this C will be mapped like a rectangle. So, this point coincides with that point, this one coincides that, this one coincides there and this one coincides there. These 2 points, because of light we can't really see into 2 points, but only one point as that we will see. This is what we call a horizontal plane. On that horizontal plane, from top side we are viewing. So, top view projected onto horizontal plane. Similarly, for side view, we will project it onto profile plane or side plane. For example, from this direction, side direction, we would like to see the object. Then we can't see C and A surfaces. What we will see is projection of this onto another plane, what we will call profile plane. We will see something like a rectangle B block. This kind of projection, what we call side view projected onto profile plane. Different views are side view, front view and top view. The different planes are what we are going to shine a light, so that we are going to construct such kind of front views onto the vertical planes, top views onto a horizontal plane and side views onto these side planes or profile planes. If we do such kind of projections, the complete information about the object we are going to get. We follow different notations for these objects. When we are projecting, there will be points, lines on the drawing sheet. So, based on which view we will note the symbols. For example, any view, top view if we are looking at, usually we project it onto horizontal planes. The lines, points are noted as A, B, C, D and so on, or perhaps 1, 2, 3 and so on. If it is a line, we show it by AB line, maybe PQ line, all these are lowercase letters. Any points, a lowercase letter we will show, a single one. If it is a line joining 2 letters A, B as one line in lowercase letters and followed. If it is a front view, which we usually project it onto vertical plane, we use a symbol prime, the dash, same lowercase letter A, but A dash or A prime. If it is a line, A prime, B prime, we will note it. If there is a letter A prime, B prime or A prime, it indicates that we are on the front view. Without prime, we are on that top view. If it is side view, we show it by 2 prime notation. same lowercase letter, but 2 primes indicates that it is a side view. For example, let us consider an object which we are showing A, maybe B, C, D. If we are showing that without any primes dashes, it indicates that it is a top view. If something like A prime, B prime, C prime, D prime, if we are showing, it indicates that front view. Similarly, for side view, any of these, we will show it as double primes. Instead of letters, if we are using numbers, similar kind of style we will follow. In later classes, we occasionally use two words above and below, frequently in front and behind. This indicates that any above below lines, if we come across, those for horizontal plane definitions. With respect to that horizontal plane, we will talk about above the plane or below the plane. So, a horizontal plane, above that, below that, we talk about position of the reference position of that object. If something like in front and behind, there is a vertical plane, in front of that plane, how far that object is present, behind the plane, how far that object is present. This is the standard words what we use. That indicates that with respect to either horizontal plane or vertical plane we are referring. To describe about any picture in the overall perspective, we use projections. These projections are mainly two types. One are parallel projections, other one is converging projections. In the case of converging projections, the objects may look small, may look large, because these points are going to converge onto a plane. For example, if I have a rectangle, if we are looking at converging kind of planes, all these corners will be converged to a single point. If so, then if we are making any plane, the object may look a very small object with proper scaling, or it might look very large object. The other kind of projections are called parallel projections. In that, this object size hardly changes. Usually converging drawing used for perspective drawing. We will learn more about that in the later classes. For parallel projections, which are quite common for our engineering drawing course and machine designing kind of courses, there are two types of projections exist. One is orthogonal projection, other one is oblique projection. These orthogonal projections are also divided into two parts, mainly multi-view projections, the other one is axonometric projections. In multi-view projections, we have these front view, top view and profile view or perhaps side views. This is the way an entire object will be projected onto different planes, show at suitable locations, something like front view, top view and side view. That kind of things we will go with orthogonal projections. In axonometric projections and oblique projections, the complete object will be shown, but as a pictorial drawing. So, the object might be slightly skewed and we may not get entire information about the object. In multi-view objects, we have different views like front, top, side, perhaps from back side and many views available. So, entire object will be clearly visible for this orthogonal, especially multi-view projections. In our entire course, we will mainly focus on these multi-view drawings. So, which projection is good to represent a picture? Let us look at different perspectives of these drawings, especially the projections. For example, here a multi-view projection, a pictorial drawing and a perspective drawing are compared. In multi-view drawing, we have different views by projecting it on different planes like vertical plane, horizontal plane or profile plane. In the case of pictorial drawing, it represents three sides of an object in one view. So, all the three sides like first one, second one, third one, without splitting into three different things, we show it on one picture. For example, let us look this one also. All the three views are available. But when we are drawing it on the sheet, it might be slightly skewed. The object might be rectangular on that top surface, but when you are representing, it might look like a parallelogram. This kind of things naturally comes out from this pictorial drawing. If it is isometric drawing, is also a type of pictorial drawing, but based on three lines which we call isometric axis. Rather than showing it on different axes, we fix something named isometric axis, which consists of a vertical line, perhaps this is the vertical line, and two others with 30 degrees square on either side of it. So, if we are going to look at, this is the vertical line, something like 30 degrees on that side and also on that side 30 degrees kind of representation we will see. Such kind of things, if we can construct it, that kind of drawings are called isometric drawings. The intersection of this vertical and two others would be at lower front corner of a block with square corners we will see. More about this pictorial drawings, especially the isometric drawings, we will learn in orthographic projections second module. A multi-view drawing having different views, it accurately presents the object complete details. We are not going to lose any information, we are not going to create any aberrations while looking at. For example, the monitor in front of you, if we are looking normal to that plane, it may look like a rectangle, but if we are looking from sideways, it might look like the projection might look like a parallelogram. So, by having a view, projection view, multi-view, we can straight away represent what is length, what is width, what is height and this kind of things without making any aberrational issues. So, it accurately gives that complete object details and shape and size. In the case of pictorial drawing, it gives us directly the object visualization. Though the dimensions and other things slightly skewed, at least on 2D sheet, it straight away gives us visualization of that object. In the case of perspective drawing, the object more like it looks more like what our eyes perceive. If we are looking a object which is slightly inclined to us, how it really perceives at our eyes, the similar kind of representation we go with perspective drawing. To construct multi-view drawings, a slight skill set is required. That means, training to visual the object, represent that visual onto the sheet requires slight intuition. In the case of pictorial drawing, the main objection is shape and angle distortion happens. So, the advantages are shown in green colored dots, the disadvantages or problems are shown in red color dots. So, multi-view drawings always requires slight intuition about the object what we are looking, how to represent that into different views on the sheet. In the case of pictorial drawing, a circle, if we are looking at an inclined direction, it might look like an ellipse. For example, here we are seeing that kind of elliptical thing. A circle here looks like an ellipse. Similarly, a rectangle looks like a parallelogram. Right angles, this one, this one, this one, this right angle completely looks like obtuse kind of angles. This kind of problems comes at pictorial drawing. If we are looking at perspective drawing, these are bit difficult to create it on the drawing sheets. Size and shape distortions happens. For example, if we are riding a bicycle or driving a car, the road is supposed to be a parallel lines from one end to other end. These are never ending lines which supposed to go at least for that short span of that road. But when you are taking a picture or perhaps looking through this perspective drawing, these two lines looks like they are going to intersect. So, a distortion in the width will be introduced. So, on a drawing sheet when we are representing these road and other objects, it looks like they are going to converge. So, this kind of problems exist for this perspective drawing. In that context, projection of object onto different views, different planes defines everything about that object in terms of shape, size and other details. Mainly, two planes are widely used. These planes are called vertical plane, vertical to that base, other one is horizontal plane. Based on the directions, if it is on x axis horizontal plane, if it is on y axis vertical plane, we will define. The other plane is profile plane. That profile plane can be on this side or perhaps on that side also. These are additional details. The principal planes or the main planes what we are referring are vertical planes and horizontal planes. Side planes are always be profile planes. The other planes are called auxiliary planes. These auxiliary planes can be auxiliary vertical planes, auxiliary inclined planes and profile planes. For example, let us look at these auxiliary planes. So, horizontal and vertical planes, the vertical one and the horizontal one always fixed. Now, we would like to take any other plane inclined either with vertical plane or horizontal plane. Let us pick such kind of plane as this one, the one which is shown in magenta color. This auxiliary plane also in the vertical direction, vertical to that horizontal base. However, it is an incline to vertical plane by certain angle, some theta. If we are looking at more details, this auxiliary vertical plane perpendicular to horizontal plane. For example, let us look at our drawing sheets. If I would like to represent any object on this drawing sheet, the drawing sheet, this is what we call horizontal plane, and this one, this is horizontal plane, and take one more sheet, make it perpendicular to that, and that sheet what we call vertical plane. So, this is vertical plane which is making 90 degrees with the horizontal plane, and horizontal plane is this. If we want to construct any other plane, for example, let us pick the geometry box. Vertical plane is 90 degrees with the horizontal. We can construct one more plane, normal to horizontal plane, incline, incline with the vertical plane. Such kind of planes are called auxiliary planes. So, let us go back to our presentation.